Hello everyone, my name is Anshu and welcome to my channel Bottleneck. This is an Agenti AI cookbook series. In this series, we are going to learn and implement the design patterns for AI application. A quick recall, in our previous video, we learned about the context cascade pattern. We also discussed about the context engineering and effective agentic system. In case if you have missed on my previous videos, I will be sharing the link in the description. Alright, in this video we are going to implement a use case for context cascade pattern, that is content generation workflow. I have divided the implementation in two parts. In part 1 we will talk about the setup for the project, like the LLM keys, how to get them. We will analyze the problem statement and break it down into multi steps. We will also look into what is the context here and how context will propagate or cascade from one prompt to another. We will be implementing prompts using LangChain expression language. Our target is to implement the design patterns and highlight its behavior. In part 2, we will continue with our implementation and we will implement the land graph and see the context cascade in action. We will learn few concepts of LangChain and land graph in the process, and I will be sharing the code over GitHub and sharing the link over the description in the video. Alright, so what is the content generation workflow? Now, as a business user, they require a high quality content, which is an article, a marketing material, a product documentation, or a training guide or report or anything else. It is time consuming, it depends on a lot of skilled workers. It is inconsistent in tone and quality because it goes from hand in hand from people to people. It is hard to scale across team. Every scheme team has its own bandwidth and capabilities. Creating good content is not a single step job. That is the bottom line. All right. So we need to create an application that can automate this content generation, and it is very generic as we know from the definition. How we are going to do it? We are going to divide this problem into multi steps. The step one would be user has a common interest, a topic, a basic idea, and based on that we create 5 topics that will be created by an LLM using the knowledge that LLM has. Then in the second prompt we will be selecting best out of those 5. So this way we eliminate the bias, if any we have, and we replicate the human behavior, that humans have a discussion among them and select the best out of what they have. Now based on the selected topics we create a detailed outline which has couple of points. Now based on the top 3 points, we are using only top 3 points for our demo purpose, we create a draft. Now that draft goes for the review in the final prompt. So this is the overall structure of the cascade. So this is how we are cascading and we are controlling the implementation of this entire workflow. All right, so now coming down to this, what we have used as a pattern, first is the context cascade, as we see, where the context is being propagated from prompt to prompt. What is the context here? As we know, the context consists of prompt engineering, RAG, state or memory, or state or history, memory, and structured output. Here we don't have a RAG because it is not specific to any domain or any specific content. So it is very generic, no RAG. We have prompts, we have state that will be coming down from the line graph. So state basically holds the intermediate information or the history. And finally a structured output, because the AI output will be tailored and will be propagated as the entire context to the next stage or the next prompt. Iterative context building, as we see that the outline will have couple of points which will be used to build or the draft this section, but while doing so we want to avoid the repetition. So whenever it is creating a draft, it will also take into account the previous point that has been already used. Finally, once the draft is created, it will self review itself. Here LLM will be used to review the final draft, and it will review on the clarity, tone and grammar. All right, so let's begin. For LLM keys, I am using Grok. So you can go to Grok console, the link is mentioned here, and create your own key, or you can use LLM from any other way, any other model that you like. It is up to you how you want to do it. Process is going to be the same. All right, I have created a util for this. Let's import it as my util, my LLM. All right, now let's first initialize the LLM. So I am creating an LLM of my own using Grok. All right. As we see, it returns a chat Grok. All right. This is one of the component that we are going to use in the LangChain expression language. Next, we need the prompts. So what is the first prompt? First prompt is the idea. Let's take a look. What was it? Idea prompt. So we need to generate 5 topics based on the user query. All right. So let's create the idea prompt. Let's name it idea prompt. Okay. So what we need for a prompt? Let's review the context. In context, we have prompt, we have state. This is propagating from the line graph, and we have structured output. So we will be using prompt and structured output. So let's import it first from langchain core dot prompts import chat prompt template. We will be using chat prompt template to create the prompt from langchain core dot. We need output parsers. So what do we need for? Whenever a chain is executed or LLM is executed, it will give you a set of values or a dictionary of values where you will have a lot of information. We don't need all of them for our use case. We need AI message as a string which we can append to our context. So we will be using the string output parsers to extract the string, the AI message from the LLM response. Let's create the prompt, idea prompt. All right. So in idea prompt, what do we need? It's going to be chat prompt template from template. So we have different message, uh, different ways of passing the context or the information to the LLM. The from messages where we can pass on tuple of messages, where we have more flexibility, like we can pass the roles, we can pass different type of messages, AI message, human message, tool message, and whatnot, that we are going to see down the line in our series. But for our use case, we will use from template where we can pass one liner. Okay, so what would be your idea prompt? So it is generate 5 content ideas, 10 words each. We are limiting on the number of words for the sake of our demo for the query. All right, so this query is being fed by the line graph as the state. This constitutes our context. Now let's pass it on to the lang chain and create a chain out of it. Let's create an idea chain. So it's going to be, the first component is idea prompt, and the second component is LLM, and the third component is string output parser. All right. So what happens now? This chain it returns a runnable which takes an input as dictionary and returns a string. So how does actually it works? Now the chain has 3 components as we have seen. First is the prompt. Basically that prompt template fills in variable from the input dictionary. So when we are invoking it, we will be using our dictionary as the input, where key will be the query and value that will be propagated from the UI or from the user input. The next is the LLM itself, which will generate the response, and finally the string output parser that extracts the plain text string from the AI message. What is the benefit of using this? First is the type safety. It is generic type. It clarifies what goes in, what comes out. Second is it has a uniform interface. It supports invoke, stream, and batch in the synchronous mode, and similarly it goes for asynchronous mode as well. And it is a composite chain, basically binded by a pipe. So we can use this chain with multiple prompts as well. But for sake of our implementation, we are utilizing line graph. The reason is we will learn more about line graph and we will be using more line graph going down our series aggressively. All right, so let's create the another chain. The another chain is what? The selection of best topic. So selection of best topic. All right, so let's name it as select topic prompt, and again it's going to be chat prompt template from template. Now the message from the below ideas, pick the best one. All right, now so we provide the ideas will be the one that we generated previously. So let's make it an ideas. Again, this value will propagate from the state. So from prompt 1 to prompt 2, whatever happens through a node which will be part of the graph. All right, so let's create a chain here. Again, it will have the prompt and the LLM and the string output parser. All right, so we have two prompts. Now let's create the third one is the outline generation. All right, in outline generation, again we need an outline prompt. Chat prompt template dot prompt template, and again a one liner. Create a detailed outline in 20 words for the topic that we have in hand. Okay, so now we have the outline created. Let's create the outline chain. Again, same outline prompt, LLM and string output parser. All right, so now we have three prompts in hand. Now let's create the fourth one. That is, once we have the outline, we need the section draft. All right, so write section draft. Okay, so to write a section draft, we need a section prompt. Section prompt. All right, so section prompt will have a chat prompt template from template. From template. So whatever we are passing here as input to the from template, everything is the human message. It is not AI message. When we do this using from message, we have a flexibility. We can pass human message or AI message or tool message, anything that you like. All right, so now let's, so for writing this section, what all we need the topic, we need the point, and we need the context, so that when it is iterating, it should not uh, repeat the same point again. All right, so write a section for topic, and we provide the topic, then the section point, that is the point itself, and the previous content. Now LLM itself will understand that what it has to do when it has the previous context. When it has the context, it will not repeat the previous value. All right, so we have three values passing in and creating the draft. So now finally, even if by any means, if LLM creates or does some mistake here, we need a reviewer. So we need to have a review, and it will have a review prompt, which will be again chat prompt template dot from template, and again one liner. So improve the following content quality, that is what we want. Improve the following content for clarity, tone, and and grammar. Just let me check if we are. So it will be clarity, tone, and grammar. Okay. So clarity, tone, and grammar. And we also limit the output words or tokens so that it should not incur a huge cost for maximum of 20 words. All right. So now we provide the draft. All right. So we have the draft here. Let's create the review chain. Again, review prompt, LLM, and string output parser. All right. So this completes the implementation of different prompts. Now, a couple of things to note. I have used the LLM, only one LLM across all the prompts. Now, in real-time scenario, based on the business requirement and the load that a prompt has, the nature of LLM or the type of model can change. Given that if you have a very small or subtle job to take care of, you can go with a small lightweight models. If not, you can go with more complex and a model with higher context window, which again the tokens are costly, so you can optimize accordingly. All right, so now this completes the first part of it where we have implemented the initial step, understood the problem. If you enjoy this video, please like and subscribe, and we will see you in the next video where we are going to implement the rest of it, the entire line graph, and see the cascade in action. Thank you.